First, notice that both answers are binomials where the two terms are being subtracted. Remember that conjugates always have opposite signs for their second terms, so when you multiply the lasts in FOIL, it will always be a positive times a negative, which is negative. Second, notice that the terms of the binomials are all perfect squares. Let me explain because this requires us to examine each term carefully. Look at the numbers in the terms first. These are either coefficients of the variables or constants, but either way they have to be perfect squares. How can we tell if they are? If you look at the list to the right, you'll see all the perfect squares from the multiplication tables you learned back in elementary school. These would be very helpful to know by memory, so make sure you take the time to memorize them if you don't know them yet. As we compare the numbers in our binomials to our list of primes, we can see that 49 is 7 squared, 64 is 8 squared, 16 is 4 squared, and 25 is 5 squared. So they are all perfect squares. But what about the variables? These are actually very easy to identify. All we have to see is whether or not all the variables have even exponents. Here, both x's have an exponent of 2, so we know they are perfect squares as well. We could separate them each into x times x. This seems like it might be a lot to remember, but that's why we call this pattern the difference of squares. It must be subtraction, a difference, and you must be subtracting perfect squares. Remember that these answers came from multiplying conjugates together, so as we move on to factoring them, all of our solutions will be pairs of conjugates.